So what we're going to do is shine this light through the semicircular dish full of water, and we're going to measure the angles that the light gets refracted. All right, so what we got here is we got this semicircular tray of water, and we're going to try to put the exact middle of the tray on the intersection of this crosshair. This tray is 11, almost 12 centimeters, so I should put this close to the 6. It is, okay, so that's good. Now, what I'm going to do is I'm going to take this ray box and I'm going to put a cover on it so that only one little ray shoots out. And I've got this angle going on here, right? And it's going to go over this line. All right, now where does it refract? I see it refracting over here. Okay, so we need to have a little pencil mark right there. Okay, now you take this tray away, try not to spill any water, then using this thing called a ruler, from the intersection to that dot, and that's where your refracted ray is. Angles. Okay, now the angle that we're going to measure, what we're going to do is we're going to take this protractor. It's very positive. The negative version is called a contractor. You see that that's where I put the 0 on the normal, and then I start measuring towards this incident ray. The angle of incidence is 60. So the angle of incidence equals to 60. Let's just say 60. Now, to measure the refracted ray, I'm not going to use this one here. I'm going to, let's just erase that. Okay, I'm just not going to use it. I'm going to line up my protractor so that the 0 is on the normal. I put this 90-degree angle line on the perpendicular line, so that is where I start. Make sure that this center is on the intersection, and I go from 0 to, I think that's a 41. So the angle of refraction is 41 degrees. So from here, I say left side is n1 sine theta 1, and that's my incident side. And my right side, I have n2 sine theta 2. So n1 is air. So this was air, and that's water. So the index of refraction for air is 1.00, and the index of refraction of water is 1.33. And so I put 1.00 here, and then sine, that angle was a 60. This angle here is 60 degrees. So I put 60 there. I don't have to put brackets. And then over here I write 1.33 is sine 41. Now you're going to calculate a number here, and you're going to stop. And you're going to calculate a number here, you're going to stop. It's going to equal each other, and you're going to say left side equals right side. Therefore, n1 sine theta 1 equals to n2 sine theta 2, except you're going to put numbers in there. Okay, and that's how you prove Snell's law using this activity. Put this little thing here, and you point the n to the normal. Now this was water, right? And this here is air. So we're looking at angle number, let's say this is 1, right? So from 180 to 142, that's a difference of
38 degrees.
So this is 8. Now that ended up over here, and from the normal, that is 10, 20, 27 degrees. So we're looking at Snell's law, n1 sine theta 1 is equal to n2 sine theta 2. And the left side, we had air. So the index of refraction for air, n air, is 1.00. And the index of refraction for water is 1.33. I already know 1.00, and I know 1.33. And then I'm going to write sine, and the angle was 27. That was the refracted angle. And this was the incident angle.
38 degrees.
So you do your calculations and see if they equal each other. You do that for each one of these angles.